Okay, here is another problem where we have three batteries. First one, second, third. We have two loads, both of them have the same resistance, and we have a switch, and we are said that the switch is closed. What does it mean that the switch is closed? That delta, the potential difference across the switch is zero, and the current just flows through over here, okay? So we can treat this as just a piece of the wire if the switch is closed. What we need to find? We need to find I1. Okay, so again, so the first step is to define the direction of all currents. So I will define I3, I will define I2, again, so it's more or less arbitrary naming scheme and arbitrary directions. For I1, the direction was already identified for us, and yeah, so what is called I1 is known. It's the current through the battery. Very good. So next step is to show the directions of the potential difference across each of them. I hope you already become very familiar with this procedure, and you don't need much help from me for that. Okay, that will be the potential difference across all of them. So the next step is to define the loops. Well, let me just start here by the large loop. We'll define A as the large loop over here, and B, well, let's define B as this loop. Okay, so what is the node loop for the node alpha? For the node alpha, I will get how many currents are incoming? Only one, it's I1. How many currents are outgoing? It's I2 and I3. I2 plus I3. So then I will apply the node rule, the loop rule for the loop A. Well, I start from the battery 1, I get 4 volts, the direction of the loop coincide with the direction of the potential difference here. Then I will encounter this resistor, and the direction of the loop is opposite to the direction over here, so it will contribute with a negative sign, minus 2 ohm. Well, let me start from writing the current. Minus I1 times 2 ohms. Then, well, what else is here? So then I go around this loop. Okay, so and I see another battery contributing here, which gives me a potential difference of 2 volts. The direction of the loop coincides with the direction of delta V in there, and therefore I will write plus 2 volts. And that's it. And then I completed the loop. I came back to where I started. So therefore it will be 0. Okay, and here I immediately see, by looking at this equation, that I can actually find the current I1 without any further information needed. Okay, I just can solve for I1. I don't need to write the rule for the loop number, for the loop B. Okay, I can just proceed finding I1 from here. So let me simplify this equation. I'll get 6 volts minus I1 times 2 ohms and 0. And this I am solving for I1, and I get 3 amperes. And that's it. Okay, so I didn't need to use the current rule here for the node alpha. I didn't need to use the second loop here. It was sufficient to use just the loop A to actually solve this problem. Yeah, I mean, sometimes it happens that way. Not often, but sometimes the problem simplifies significantly. But since it's so simple, let's now also find the current through the battery too. Okay, so nothing changes. The only thing we want to do is to find I2. For this, as you can see, we will have to write the loop B, all right? So for the loop B, the same figure, so the same thing applies. Please stop the video, write that, write the voltage rule for the loop B. This is what I get. It's 4 volts minus I1 times 2 ohms. Okay, so I'm going in that direction over here. So the next thing I see is that the directions coincide, so it's plus 12 volts. Then I see that resistor, so the potential difference in this direction, the loop goes in that, so it will contribute with negative sign. Okay, 12 volts minus I2 times 2 ohms, and then I come back to the point where I started, so it equals 0. Very good. So I1 I already found, so I will use this information over here. So I get 4 volts minus 3 times 2 is 6. Okay, minus 6 volts plus 2 volts minus I2 times 2 ohms and 0. So now let's simplify this part. So 4 minus 6 is 2. Minus 2. Minus 2 plus 12 is 10 volts. So I get 10 volts minus I2 times 2 ohms equals 0. And this I can solve for I2 to get 5 amperes. Let me indicate it here. So I2, well, there is no space really left, so let me just write that I2 equals 5 amperes. All right. Finally, let's just find the current I3. Okay, so for the current I3, what we're going to have, we will just apply the node rule over here. So from that, we will see that. So I1 equals to I2 plus I3. Let's just substitute what we found before. So what we found before is that 3 amperes is given by I2 is 5 amperes plus I3. And this I can just solve for I3. I will get I3 equals to negative 2 amperes. And that solves for all currents in the circuit.